In this video, I'm going to go over a few applications using linear equations in two variables, mostly focusing in equations that are, creating equations that are in the slope-intercept form. Y equals mx plus b, where the b is your y-intercept, the point 0, b. And when it comes to applications, we want to, the keywords that we're going to see is that this is a fixed point, fixed amount, fixed point is the start, okay? Something that does not change. Now the slope, it's something that changes over a period of time, distance, and so on. This is a rate, okay? So using the slope-intercept form, we're going to solve a few applications. Let's see. Example 1. Perla calls a plumber because she's having problems with her kitchen. The plumber charges her a flat fee, meaning something that is not going to change. A flat fee. And 12.50 per hour. Per hour. Okay? Write a linear equation where y is the amount of money. So y is the amount of money charged based on the amount of time. X is the amount of time. So using that the slope is something is going to change, which is going to be your m, and the b is something fixed, okay, something that does not change, we can say y equals 12.50 x, because it's the amount of time, plus the flat fee of $16. And this is your linear equation. Okay. The 12.50 will change every hour, and the 16 is the starting amount. Then part B says, how much will Perla pay the plumber if it takes 5 hours to fix the problem? Well, now simply we're just trying to find the money. So we're going to say 12.50 times 5 plus 16. Let's go ahead and multiply 12.50. That gives you 62.5. And that's how much money it will cost for the plumber to fix that issue when it takes him 5 hours. Okay. Let's see example 2. Lee and May are no longer happy with their cable provider. Their new provider, Cable Right, charges them $28 for a visit. Charges $20 for a visit to their home, and $12 per hour to set up the service. It took the cable man 2 hours to set up the service. How much was charged to Lee and May's account? Step 1, we need to first construct our linear equation. So construct our linear equation. So we need to know what will be our slope and what will be the b, the y-intercept. So the slope, $12 per hour. So this is what's going to change. And then just to go and see what's the, to change the cable, is $28. So that's the fixed amount. So it doesn't give you any specifics on the type of variables to use. So we can continue using y and x. So we can say y equals 12x plus 28. This is our linear model, okay? Linear equation. Now that we have this, we can simply substitute the amount of hours it took, okay, because X is hours, and Y is the money, okay? The amount of hours it took to fix. So it took 2 hours to install the new cable. So that gives me 52. Oops, ignore that. Y equals $52 they had to pay. Okay, example 3. It has been shown that having a student leader in the classroom helps students succeed. At Valencia College in 2007, 176 sections, okay, or classes had supplemental learning leaders. In 2010, 325 sections had supplemental learning leaders. This shows that the problem has experienced a tremendous growth. Use the given data to find an equation of the linear that predicts the future growth of the program. So use the given data to find an equation of the line that predicts the future growth of the program. So in this, we're only writing the equation of the line. So we need to write the equation of the line. Now, if you notice, we are given 2 points. Year equals the number of sessions, and then year equals the number of sessions. Okay, so we're going to use our slope formula to first find the slope, because if we're trying to write an equation of the line, we need to have the slope and a point. In this moment, we have 2 points. So we are missing our slope. So x1, y1, x2, y2. Let's go ahead and substitute those values. So I have 325 minus 176 divided by 210 minus 207. So 325 minus 176, 149 over 3. So then I don't think 149 divides by 3, but let's try it. No, it does not. So that will be our slope. Now that we have the slope, using the point slope formula, we're going to write the equation of the line. Okay? Using the point slope formula. I'm going to use the first point. So I have y minus 176 equals 149 over 3 times x minus 207. I need to solve for y, so I'm going to go ahead and distribute this right here. Okay, remember when you are multiplying fractions, just keep multiply the top times the top and the bottom times the bottom. I can go ahead and not this one. Put this over 1 here to help me. This gives me 149x over 3. And then I have 149 times negative 207, negative 2007 divided by 3. And that gives me a very big number, 99681. Then I'm going to go ahead and add this. Okay. Divide by 3. So now I have negative 99681 plus 176. Okay. Now let's go back to the problem. So we're given a scenario, right? We're given 2 points, and we're being asked to find the equation of the line. Okay, so in order to write the equation of the line, we need to remember that we need a point and a slope. But we're given only 2 points. So what we first do is find the slope. So this is the first step. Step 1, find the slope. Once we have our slope, okay, we use the point slope formula to write the equation of the line. Okay, now keep in mind that everything after that is just simplifying it. Okay, that's the only thing we're doing. We're just simply simplifying the equation. Okay, then I substitute my point and my slope. I distribute here. So I did 149 times 207. That gave me a big number. Then I divide that number by 3, and it gave me 99,681 negative. And then the last step is to add the negative 176. I add it to both sides, and then I have my linear equation over here. With this equation, I can find out what happens after certain years. Okay. Let's see the next example. In CERN University, the number of students who major in psychology in 1995 was 855. So in 1995 was 855. By 2010, the number of students who major in psychology increased to 1,096. So by 2010, increased to this number. Use the given data to find an equation of the line that predicts the future growth. So we need to find another equation. You notice it was just like the previous example. We were given 2 points. The year 1995, the number of graduates was 855. And then the year 2010, the number of graduates was 1,096. Using the 2 points, we first need to find the slope, so then we can write the equation of the line. So following the same procedure that we did in the previous example. Okay, so formula, label your points. Okay, substitute your points. Make sure you substitute correctly. Can easily make a mistake. So 1,096 minus 855 gives you 241 over 2010 minus 115 gives you 15. Then we try to simplify 241 by 15. I don't think it reduces. And that stays like that. So I know we have some fractions that we might not like, but that's okay. Okay. So that was step 1. Find the slope. Step 2, we're going to use the point slope formula to write the equation of the line. Okay. So now I'm going to use the first point with the slope and substitute. So I have y minus a55. My slope is 241 over 15 times x minus 195. Now I need to distribute. Okay. I need to distribute. Again, keep in mind, when you multiply fractions, multiply the top times the top, bottom times the bottom. Two 41x over 15. Then we're going to have minus, what is that? 241 times 1995 gives you a fairly large number, divided by 15 gives you a similar, not so large number. 32053. Now we're going to add the A55. Okay. So I have y equals 241x over 15. Now I need to add the A55. I forgot. Negative 32053 plus A55 gives me negative 31198. And I have successfully constructed my linear equation passing through the two given points. Okay. So again, you're given 2 points. In order to find the equation of the line, given 2 points, you need to first find the slope, and then use the slope in one of the points and write the equation of the line using the point slope formula. Okay. See this example. After visiting the Titanic, Captain Samantha and Commander Boris are taking the SSN-21 Seawolf submarine back to the surface of the water. They start 1,000 meters below the surface of the water and ascend at 55 meters per hour. Write an equation in slope-intercept form to model this situation, where d is the distance underwater and h is the time in hours. So they start 1,000 meters below the surface of the water, and they ascend at 55 meters per hour. Okay, d is the distance and h is the time in hours. So what is my slope and what is my b? The word start is your key point for the slope, for the b, and the word below tells you that you're dealing with negative number because it's below the surface of the water. The rate is 55 per hour. Now knowing that, you know that they want d for distance instead of y. 55 per hour, they want you to use h, and then minus 1,000. This is your linear model for this example. Okay. Now, part B. After how many meters below the surface is the submarine after 8 hours? So now that I have my linear model, my equation, I can simply just substitute the A for the hours and see what is the distance. Okay. So I have 55 times A minus 1,000. And the distance is negative 560. Because it's negative because they're still below the surface of the water. Okay, they're still below the surface of the water. That's why we're using the negative for distance. Okay, below the surface of the water. That's what the negative represents. Now that we can actually have a negative distance. Okay. Let's see here. Superman needs to save Lois from the clutches of Lex Luthor. After flying for 11 seconds, he is 2,251 meters from her. Then after 16 seconds, he is 2,035 meters from her. So if you notice, we're given 2 points, time and distance. Write an equation of the line in slope-intercept form to model the situation where m is the distance in meters and s is the time in seconds. Okay, so just like the before, let's go ahead and write our points. 11, 2, 2, 5, 1, and then 16 to 35. Okay, I'm going to use my slope formula to find the slope given 2 points, and then I'm going to use the point slope formula to write the equation of the line, because I need my slope, and I'm not given the slope. I'm given 2 points, but I am able to find it. Make sure we're careful when substituting the points. Okay. What is that? 2,035 minus 2,251 negative 216 over 5. I don't think this is going to simplify, but we shall see. Yep, that's the most it simplifies. So it stays 216 over 5. Okay, now that I have my slope, I'm going to use the point slope formula to write my equation of the line. Okay. So I have y minus y1 equals m times x1. Okay. So using the first point, I have y minus 2,251 equal 216 negative 216 over 5 times x minus 11. I'm going to go ahead and distribute, running a little bit out of space. Let's see if I can fix that. Okay, perfect. Now let's go ahead and distribute. Remember, when we're multiplying fractions, we multiply the top times the top, the bottom times the bottom. Okay. Negative 216x over 5. It's going to be plus 216 times 11 divided by 5. We get a fraction. 2376 over 5. 2376 over 5. Nothing wrong with a fraction. Then we add this guy. Okay. Again, we're solving for the y. We will have to change the variables to the correct variables the problem wants us to use, because if not, so let's see, what do we have? We have the fraction 2376 plus 2251. And we get a nice decimal. Let's keep it like that. It doesn't matter. 2726.2. Much easier number to deal with. Okay, now I have created my linear model, but I'm just going to go ahead and substitute the variables that they want me to use. They want me to use m for distance and s for time. So this should be m equals negative 216 over 5s plus 2726.2. And this is my linear model for this example. Running out of space. So the first thing I did was to realize that I was given 2 points. And in order to write the equation of the line, I need to first find the slope whenever I'm given 2 points, which I did that part. Once I have found my slope, I went and used the point slope formula to write the equation of the line. After that, it was simplifying, multiplication, adding, combining like terms and things like that. And then I substituted the y and the x for the correct variables the problem wanted me to use. Now let's see what is the second part of the question. How far is Superman away from Lois after flying 6 seconds? So using the linear model that we have created, I am simply going to substitute 6 for s. And see what's the distance. Okay. I know that we have fractions and decimals. It's okay. It's not like we cannot work with them. We just have to be careful. So when we multiply negative 216 over 5 times 6, we get negative 256, 59. 59.2. And then plus 26.2. We're going to go ahead and do that subtraction. And we get 2467. That's the distance after flying for 6 seconds that Superman is from Lois. Away from Lois. Okay. So in this video, we went over a few applications using the slope-intercept form to solve applications dealing with linear equations in 2 variables.